Hello everyone. Our project is about obesity and community health in Michigan. So here are some outlines of our project. Yeah. So the first one is about our key research questions. So our key research question is about how do obesity rates in Michigan correlated with lifestyle choices and social economic conditions. And about the data set, we have two data sets, one from the CDC's places and the other one is from the community survey data. And our another analysis goal is to predict obesity prevalence using machine learning models. So our second part is about overview of data. The first one is about the data cleaning challenge. The data set contains too many variables, such as someone with missing values. In addressing obesity, we've selectively focused on key variables representative. And the second method we use is that the race variable was reclassified for a more accurate cross-racial analysis. And the third method we use is that the instances of missing data in household income were dropped to ensure the integrity of our analysis.
Then in the next step, visualization was used to explore the data. First, histograms were used to depict the distribution of independent variables. And then in these bar charts, it visualizes the racial combination of 50 randomly selected census tracts. Then we further aggregated the data and shows the median income level of different counties where we can observe the income disparities here. We further explore the pair plot, which helps to unveil the correlation among independent and dependent variables. Then in this heat map, we were able to observe some significant correlations, such as physical activity, sleep disorders, diabetes, etc., as with obesity occurrences.
So here are some detailed visualizations based on the previous heat map, and this one is comparing racial compositions in counties high versus low obesity rate, and this one is about the income and the poverty rate across these counties. And here, these two scatter plots are based on the heat map from previous discussion, and we're using this for better visualizations for our project. This one is about lifestyle, and this one is about the racial demographics. So the significant correlations in our data set is obesity and related conditions, highlighting strong correlations between obesity and physical inactivities, sleep durations, diabetes, stroke, and overall health status. Second one is about the health and socioeconomic features, pointing out strong correlations of education background, poverty rate, race, and household financial status with disease occurrence and health behaviors. So the behavioral correlations revealing the correlations between obesity and binge drinking, shedding light on the counterintuitive relationship between drinking and obesity. So here's our analysis summary.
So in this part, we have two analysis methods, the statistics and machine learning method. About the statistic part, which is multiple linear regression model and ANOVA for the correlation analysis. So here are some models. Model 1 is about the multiple linear regression model, and model 2 is about ANOVA, and model 3 is also about the multiple linear regression. So based on the models, we found that the social economic factors like race and household income are correlated with obesity prevalence. And the other finding is that there was a statistically strong correlation between personal behavior indicators and obesity rates. So next part.
Then in the next step, machine learning models were explored with classification methods. This was because classification is used in machine learning to predict the decreed categories in the dataset. And we have selected 4 classifiers as below. After experimentation with multiple models with these methodologies, which includes variable selection, pre-processing of data, and hyperparameter tuning with the models, we were able to select the best models and do the comparison. So for this comparison, we can observe that the last 3 models performs much better than naive Bayes models. The accuracy from cross-validation score is higher than 88%, and the misclassification rate is so much lower than the naive Bayes results. And after that, we use visualization of ROC curves to compare the area under the scores. So it is observed that random forest models performs the most impressive results. That's 0.96 AUC score. So with this debate between the two methodologies, we understand that 2 scores, ROC and the accuracy scores, can be used to evaluate different aspects of the results.
So our next part is about the conclusion and implications. So first one is about the limitation and further steps. So the first part is about the ROC. As we can see, the ROC is an effective tool dealing with the binary variables, but categorizing the obesity rates like this will reduce the accuracy of the data set. And the second limitation is about the values. Because the values are numeric, we cannot use pivot table for the data visualization. And the third one is about the statistic analysis. The p-value is pretty small. It's a good sign, but it may be due to the large data set rather than the strong correlation between the variables. So that's our next step.
Okay, so here comes our conclusion. Our research reveals a strong link between daily life choices, local environment, and health. We find higher obesity rates in areas dominated by racial minorities or low-income communities. So obesity is critical public health concern, driving up healthcare costs and lowering life quality. Our findings highlight the need for comprehensive strategies to address these escalating threats based on the unique characteristics of each communities. And here's our presentations, and thank you so much for watching.